In today's video, we're taking a deep dive into one of the most formidable missile systems in the world at the 2026 Russian 9K720 Iskander missile launcher. Though this channel primarily covers the latest in automotive and military vehicles, this missile launcher is a marvel of mobile weapons engineering and deserves a detailed breakdown. So, if you're fascinated by the integration of technology, mobility, and military precision, stay tuned as we explore every element of the Iskander system. The Iskander missile launcher, also known by its NATO reporting name SS-26 Stone, is a mobile short-range ballistic missile system developed and produced by Russia. It represents the pinnacle of Russian tactical ballistic missile technology and is one of the most advanced land-based systems in the world. The 9K720 Iskander was developed to replace the aging OTR-21 Tokka missile systems, offering superior range, mobility, accuracy, and survivability. Let's start by looking at the system's overall design and layout. The 2026 Iskander system is mounted on a high-mobility 8x8 wheeled chassis known as the MZKT 79306 Astrolog, built by the Belarusian manufacturer MZKT. This vehicle provides excellent off-road capability, allowing the launcher to travel across rough terrain with relative ease. The wheeled chassis also ensures rapid redeployment, a critical factor in modern mobile warfare. This mobility is key to the Iskander's survivability and effectiveness on the battlefield. The complete Iskander system includes several components: the transporter erector launcher, TEL, command and control vehicles, reloading vehicles, maintenance and support units, and even meteorological stations. However, the most iconic part of the system is the TEL vehicle that carries two ready-to-launch missiles in vertical canisters. This TEL can launch both missiles in rapid succession and then relocate quickly to avoid counter-battery fire or aerial detection. The Iskander missile itself is a solid-fuel, single-stage ballistic missile. It has a range of around 500 kilometers, just within the limits imposed by the now-defunct Intermediate Range Nuclear Forces, INF, Treaty. However, some variants, particularly those developed after Russia's withdrawal from the INF, are rumored to have extended ranges beyond 700 kilometers. These missiles can carry conventional or nuclear warheads, and they're designed to evade interception by using a variety of advanced countermeasures. Now let's talk more about the payload and guidance systems. Each Iskander missile can carry a warhead weighing up to 700 kilograms. These warheads can be configured for a variety of roles, including high explosive, cluster munitions, fuel-air explosives, electromagnetic pulses, and even nuclear payloads. This versatility makes the Iskander a true multi-role weapon capable of targeting a wide array of military infrastructure, including airfields, command posts, missile defense sites, and fortified installations. One of the most impressive aspects of the Iskander system is its guidance. The missile is equipped with an inertial guidance system supplemented by GLONASS, the Russian equivalent of GPS. This ensures pinpoint accuracy with a reported circular error probable, CEP, of just 5 to 7 meters in its latest configurations. That means the missile can strike a target with a deviation no greater than the length of a sedan, which is remarkable for a ballistic missile. Adding to its lethality is the missile's terminal maneuvering capability. Unlike many traditional ballistic missiles that follow a predictable arc, the Iskander can perform evasive maneuvers during its terminal phase to avoid interception by enemy air defenses. It can fly at hypersonic speeds, maneuvering laterally and vertically, which makes it extremely difficult to track and shoot down. This capability is further enhanced by the use of decoys and electronic countermeasures. The Iskander missile is believed to carry decoy flares, chaff, and possibly even jammers to confuse radar-guided interceptors. All of this contributes to its reputation as one of the hardest missiles to intercept in the modern battlefield. Now, let's explore the operational use of the system. A typical Iskander battalion includes up to 12 TELs, each carrying 2 missiles. That means a single battalion can launch up to 24 missiles within minutes. The reloading process is fast, and additional reload vehicles accompany the TELs to ensure sustained operations. The missile reloads are stored in sealed canisters that are lifted and inserted into the launcher by hydraulic cranes on the reload vehicle. The launch process itself is highly automated. From the command vehicle, operators can input target coordinates and environmental data. The TEL receives this information via encrypted communications. Once ready, the hydraulic erect raises the missile to a vertical launch position. Upon ignition, the missile blasts off vertically before angling toward its target at hypersonic speeds. The Iskander system is fully road mobile and can be operational within minutes of arrival. Its ability to shoot and scoot makes it ideal for modern warfare where mobility, stealth, and quick reaction times are essential. It can operate independently or as part of a larger integrated missile network. Let's now talk about the variants of the Iskander missile system. There are several known variants of the 9K720 Iskander system, each tailored for different operational roles. Iskander M is the version used by the Russian military. It uses quasi-ballistic missiles and features advanced guidance and countermeasure systems. The M variant can carry nuclear or conventional warheads. Iskander K is a cruise missile variant launched from the same platform. Instead of a ballistic missile, it launches the R-500 cruise missile, which follows a low-altitude flight path and is harder to detect by a radar. Iskander E is the export variant of the system, offered to select allied nations. It has a slightly reduced range to comply with international arms export agreements. Iskander M1 and M2 are believed to be improved subvariants that may offer enhanced range, faster reload times, and even lower SEP. In recent years, Russia has conducted numerous drills and live-fire exercises showcasing the Iskander's abilities. It was notably used during the 2008 Russo-Georgian War, and reports suggest it was deployed during operations in Syria and Ukraine. These real-world deployments have provided valuable data for refining the system and have demonstrated its effectiveness in modern conflict environments. In 2026, the latest version of the Iskander benefits from upgraded digital fire control systems, improved satellite navigation integration, and superior communication links with the Russian military's C4ISR infrastructure. That stands for command, control, communications, computers, intelligence, surveillance, and reconnaissance. With these enhancements, the 2026 Iskander system can receive targeting data from drones, satellites, and ground-based radar units in real time. There are also reports suggesting that the latest Iskander may be interoperable with unmanned aerial vehicles for reconnaissance and targeting assistance. This networked capability represents the future of precision strike warfare, high-speed, highly mobile missile platforms guided by a digital battlefield architecture. Another key area of improvement is survivability. The 2026 Iskander TEL now includes enhanced armor plating for the cabin, improved thermal camouflage, and reduced infrared signature. It also incorporates electronic countermeasures to resist jamming and spoofing by enemy forces. This allows the Iskander to maintain communications and navigation accuracy even in contested electronic environments. The digital upgrades extend to logistics as well. Maintenance crews use handheld diagnostic tools to quickly assess launcher and missile status. Predictive maintenance algorithms can alert ground crews to potential failures before they occur, reducing downtime and enhancing mission readiness. On the mobility front, the TEL vehicle has seen drivetrain and suspension upgrades. It can travel over 1,000 kilometers without refueling, and its 8x8 all-wheel drive layout provides excellent traction across mud, snow, and sand. The cab is climate-controlled and equipped with NBC, nuclear, biological, chemical, protection for the crew. This ensures operational capability even in extreme environments. So, what does all of this mean in the grander scheme of geopolitics? The Iskander missile launcher is a tool of strategic deterrence. Its deployment near border areas sends a clear message to adversaries. For example, when Russia moved Iskander systems to Kaliningrad, it immediately heightened tensions with NATO due to the system's ability to strike targets deep inside Europe. From a military doctrine standpoint, the Iskander fits into Russia's escalate-to-de-escalate strategy. In a potential conflict, Russia might use a tactical strike with a conventional or low-yield nuclear warhead to compel an opponent to back down. The Iskander is the ideal delivery system for such a strike, here fast, mobile, and hard to intercept. At the same time, the system's export potential cannot be ignored. Countries like Armenia and Algeria have reportedly received variants of the Iskander-E. Its compact size, combined with its high firepower and accuracy, makes it an attractive option for militaries that need a credible deterrent against regional threats. In conclusion, the 2026 Russian 9K720 Iskander missile launcher is more than just a weapon, it is a symbol of mobile precision warfare. It combines brute force with advanced engineering, integrating mobility, targeting accuracy, and survivability in a single platform. Whether viewed through a military lens or as a feat of mechanical design, the Iskander stands as one of the most impressive systems in modern warfare. As we wrap up, it's worth appreciating the technological sophistication that goes into such systems. While this channel often focuses on civilian automotive updates, it's impossible not to admire the engineering that makes machines like the Iskander possible. The same principles, mobility, power efficiency, system integration, are what drive innovation across all vehicle platforms, military or civilian. Thanks for joining today's deep dive. Stay tuned for more detailed analyses on the latest machines shaping our world, both on the battlefield and the road.